Okay, hi guys. So we are back with another problem. So what does the problem statement state? So we already saw a similar pattern, but there we had a constant amount of columns to be printed. Like the stars for each column, for each row were equal. Like say for the first row, it was still like 3 columns, and the second row also had 3 columns, and the third row respectively. So it was like equal, so we didn't have much to play around with. But here we will be having a differential number for the number of columns. So here for each row we'll be printing a different number of columns. So for example, for the first row, which is the 0th row according to the iteration from zero based indexing, so it will be printing out 1 column, and it will be printing out 2 and 3 respectively. So it will be going on like that. So for as we already spoke in the last video, we'll be having a Bayes intuition. So the outer loop is for the rows for I till the number of rows, and the inner loop will be again for j till the number of columns. So okay, the outer loop part again remains static. We'll be printing out n number of rows, so that will be similar to the last question, but the inner loop is where the changes occur. So here for the first row we'll be printing out 1, but we'll be having 0 based indexing, so basically we need to iterate till I plus 1. So that will be the equation between the rows and the columns. So I will be 0, then j needs to iterate till 1. So it prints out 1 star. And then when I becomes 1, j needs to iterate till 2, which will like print out 2 stars. And the same cycle repeats 3 and 2 and 3. Sorry, let's not confuse this fact. Okay, we'll be having 2 and we'll be having 3. Okay, so that is how it works. So we'll be printing out star as usual, which is similar to the last problem, and again after the inner loop executes we'll be printing out a backslash n. So that is the Bayes intuition for this problem. Again, we didn't speak about time complexity in the last problem. Maybe we can have a brief chat about it in this problem. So what do we see? Whenever we speak in terms of time complexity, we need to see how many iterations it's going off for. So what will be the worst case? So big O always indicates the worst case. So here when we see it goes up till n, so the row iteration for the outer loop goes up till n, and the inner loop it goes from 1 plus 2 plus 3, which is again n. So why is it n? Because the worst case is 3, which is equivalent to n. So the worst case for the inner loop is 3, which is n. So again, so for each n we are doing n operations internally, so it comes up to be n into n. So the time complexity will be big O of n square. So that is how we arrive at time complexity, and the space complexity again stands at big O of 1. So that is the Bayes intuition for this problem. Let's get back to coding. We'll just see the difference between the last problem and this present problem. So that is how we'll look at it. Let me just switch over to my coding screen. Okay, so what do we change? The outer loop stays stagnant as discussed in the previous problem. The outer loop stays stagnant, so the inner loop only changes. So when the inner loop changes, what does it change to? It goes up to I plus 1. So we'll just print it out and see if it works. Yes, it works. So for the first row, we are printing out 1 star and 2 stars and 3 stars and going on. We'll just try out another case, n equal to 4, and just print it out. Yes, we are done with it. So that's it for this problem. Do let us know if you have any doubts in the comment section. Thanks.